We're now going to show you the Sandflo Separator, which is built to recover all the aluminium from metal recovered after processing with a mag-throw eddy current separator. The middle range of aluminium which passed over the first splitter can be fed into this machine. It's a dry fluidized bed separator, and it works on the float and sink principle. It's a circular vibratory driven machine. It has about a ton of a heavy sand in it, dry heavy sand, which travels round the machine under the action of the vibrator. Material is fed into this central part, and you'll notice that this central part is made from a sieving material, so that any dust which is clinging to the metal is shaken off and loosened from the metal. The metal is then spread out into the separation area, which is what we call the fluidized bed. It's the area in which air is blown through the sand to make it behave like a liquid. And then the lighter aluminium floats on the surface of the sand and passes up this first ramp and then discharges out there from the machine. The heavier zinc, brass, copper, stainless steel, the heavier metals pass further round the machine and then up this second ramp, and they are discharged further round the machine at a second chute. This particular machine will do about 1 ton per hour. It's a small laboratory machine. Here you see the blower. It's on the same structure as the Sandflo separator, and this blower blows air through a system of control valves and through a manifold into the sand, and the fluidization of the sand occurs, and the sand then behaves as though it's a liquid, and we're trying to show you here by stirring it around how it appears to behave like a liquid. It is a mine sand. We have to use a particular size range, so it's screened to a certain size range, but it is a mine sand. So here again we're showing you the fluidized area. The first of the discharge ramps, which takes off the aluminium, and the second of the discharge ramps, which takes off the heavier metals, the brass, copper, stainless steel, lead, zinc. The proportion of aluminium in a car is 70%, and it is the aluminium that represents the main principal value of the non-ferrous metals. So the recovery of clean, good quality, saleable aluminium is a most important part in the economics of the operation of a shredder. Here we see now the aluminium fed into the centre of the machine, the mixed metals fed into the centre of the machine, and then passing out through the fluidized area. The aluminium is floating on the fluidized area and passing up this first ramp. There is initially, when you start the machine, a build-up of metal on the ramp, but then eventually the ramp gets full of metal and then starts to discharge. But this period of vibration here shakes off all the loose sand attached to the metal and helps in the process of producing clean metal. Sand itself is not disadvantageous to the melting of the metal. It doesn't contaminate the metal when the metal is melted, as ferrosilicon does in a heavy media plant. And here you see the sand flowing further round the machine and the discharge of the heavy material. And here again you see the way the material builds up and then starts to then discharge, and again all the sand is shaken out. Normally the machine is conveyor fed into the centre. The holding area in the centre acts as a buffer to keep an even flow of material, and then by discharging it in this way onto the sand, you can see how material is dropping on and some is sinking. Piece of brass there, did you see it sunk quickly? You'll suddenly see the heavier metal dip down into the sand and the light aluminium stay on the surface. You notice the bubbling as the air blows through the sand, and this is the fluidized bed. And again, material now discharging up the ramp and all the sand being loosened from it. We'll now switch the machine off and we'll have a close look at the metal that has been separated. But in the top corner there you can see nicely the fluidized bed, how the air is bubbling through the sand to achieve the fluidized bed in just that one part of the machine. Here you can see that we have the heavy metals, brass, zinc, some pieces of copper there, the odd piece of stainless steel. Always the odd coin. The machine has been switched off now and it's just coming to a standstill, and we'll have a closer look at the metal now. This is the heavies, very shiny, very clean, ideal for hand picking. That's the end of a fuse, tinned copper. That's a restraining part of a seat belt. That's a bit of zinc casting, bit of copper there, bit of piece of brass, bit more stainless steel. Here's a bit of lead that it's no doubt come off a car battery or something. That's that end of a fuse. This is chromium plated zinc from car trim. Shiny and dry and clean. And this is the aluminium discharge. You can see, all aluminium. 70% of the aluminium from a car recovered by two simple processes, the mag throw and the Sandflo separator. All the fragmentizer operator has to do now is buy himself a furnace, and he can sell good quality ingots back to the car manufacturers.